Okay, so this is a review of science and technology over the past 40 years, with a few smiles along the way, hopefully, and a few speculations about the future as well. The pace of scientific development is ever increasing. It's pretty much an exponential rate. So I thought I'd have a few, couple of slides of speculation. But first of all, we'll start off with one or two jokes. So just to get you in the right mood, and then there'll be some funnies interspersed, hopefully between the serious stuff. So all information here is presented in strict accordance with the Encyclopedia Moronica. And the good news is my IQ test came back negative. Now people have heard of the Heisenberg uncertainty principle, but I prefer the Heineken uncertainty principle because I'm never sure how many beers I had the night before. I'm reading a great book at the moment on anti-gravity, and I just can't put it down. The unofficial, unabashed scientific dictionary defines elementary particles as the dreams that stuff is made of. And there are 6 times 10 to the 23 guaccas in a guacamole, and this is also known as avocado's number. A tachyon is a gluon that isn't quite dry yet. And time is what keeps everything from happening at once. Einstein discovered that time and space are relative. I've discovered that the more time I spend with my relatives, the more space I seem to need. And I was going to tell you a joke about time travel, but you didn't get it. And I was thinking about telling a joke about chemistry, but every time I do, I don't get any reaction. And that's all the bad jokes out of the way. Okay, so, well, some serious stuff now. So 40 years ago, 1982, there was no internet. It came out of a thing called ARPANET, which was ways of connecting supercomputers. In particular, it was actually the American military, and then a thing called JANET evolved, which was the Joint Academic Network, and that was the beginning of starting to connect computers together in a resilient way as well. Of course, we all remember the early days of connections. It was via dial-up with modems and bulletin boards and things like Usenet groups, which are great, but obviously we've moved on a lot since then. And then we've got the World Wide Web, which came from Tim Berners-Lee at CERN. He effectively developed one of the first web browsers and the protocols that is behind web browsing. And then, of course, we've all benefited from broadband, which we're all using right now, of course. And then, of course, mobile phones emerged principally from things like car phones. But, of course, in 1982, they weighed kilograms. I had a friend who was actually a car dealer. He had a phone in a box, and it weighed about 2.5 kilos. And then in 1982 was the first artificial heart transplant using a thing called a Jarvik 7, which is an implanted pump. So 1982, the launch of the first communication satellite into orbit via the space shuttle. Donald C. Becker discovered the first millisecond pulsar. So pulsars are collapsed stars that emit radio frequency information at a very regular rate. Now this is an interesting one. 1983, Carey Mullis invented the polymerase chain reaction, which is a major discovery in molecular biology. And of course, that's been the basis of all these PCR tests that we've been so familiar with over the past 2 years. Absolutely key in genetic studies and genetic engineering. And then French doctors identified that HIV was actually the root cause, the virus which caused AIDS. 1984, they started to retrieve malfunctioning satellites using the space shuttle, and they could do repairs in space because of the size of the cargo bay. And then they discovered the ozone hole over Antarctica in 1984. In 1986, Voyager 2 photographed Uranus and discovered that it had moons. and discovered the 5 major ones, but now we know, of course, there are at least 27 moons of Uranus. The first high temperature superconductors were developed in 1986, and then the Soviet Union launched the Mir space station, and sadly in that same year the US Space Shuttle Challenger exploded on launch, killing all 7 astronauts on board. 1989, an asteroid came very, very close to colliding with Earth. This was a big one too. It passed Asclepius, past Earth at a distance of 425,000 miles. So it's just on the other side of the orbit of the moon, so pretty close. And geophysicists estimated that if it had collided with the Earth, it would have been an explosion equivalent to a 600 megaton atomic bomb. The problem was, they found out 9 days after it passed by. I'm happy to say these days, most objects of this type are known and regularly tracked. And then, of course, 1990, the launch of the Hubble Space Telescope, but it had, of course, a serious defect in the mirror. More of that later. And then in 1990 as well, the Human Genome Project started. This was a project to map all of the information in the human genetic bank, all of the stuff, if you like, that's in the 23 pairs of chromosomes in our genome. 1991, they discovered the massive crater buried in the Yucatan Peninsula, 66 million years old. And of course, this was the Chicxulub crater, as it's called now. It's 110 miles in diameter and varies between 3 and 5 miles deep. And there it is on the map, if you like. That's where Chicxulub is. And of course, that massive asteroid, somewhere between 6 and 9 miles in diameter, paid to the dinosaurs. But what if the dinosaurs had developed their own space program? You know, they've developed a space program, flown off into space, and many years later they're on the way back to Earth, and here they are just about to return. Finally, we're home. Hope the monkeys didn't touch anything. But we've been monkeying around with rather a lot. So 1991, carbon nanotubes discovered, one of the strongest materials ever discovered. And in 1992, Pope John Paul II acknowledged the Vatican's error in their past condemnation of Galileo, only 359 years late. 1992, the Big Bang became a household phrase. It was first theorized in the 1940s, but it wasn't confirmed until very much later. And there was a landmark paper in 1992, and it was essentially about the mapping of the afterglow of the Big Bang, which is called the cosmic microwave background radiation, by a NASA space telescope called COBE, or Cosmic Background Explorer. And this mapped all the minuscule changes in the microwave radiation that's left over from the Big Bang. And those tiny ripples are actually now where the stars and galaxies first began to form in the very early universe. And this work was awarded a Nobel Prize. And then 2 further cosmic microwave background space telescopes and mapped the radiation. WMAP on the bottom right there, much more sensitive than COBE, and then Planck, which was even more sensitive than that. And they now map the cosmic microwave background radiation to enormous, enormous detail. So it's the oldest light in the universe that we can see or can measure. And it was released 380,000 years after the Big Bang, when the universe had a temperature of about 3,000 degrees. And this is what it actually looks like when you plot the map. And it's basically the cooled afterglow of the Big Bang. And the average temperature is 2.7 Kelvin. In other words, 2.7 degrees above absolute zero. And the fluctuations in this are only 1 part in 100,000. So it's quite uniform and quite even. And it's the best information that cosmologists have about the very early universe. And they're still studying this information in great detail, even though they stopped collecting it quite some time ago. But cosmology, we all know about cosmology. Lots and lots of theories in the in tray, very few proofs in the out tray. And then, of course, we back to the Hubble Space Telescope, which has taught us so much about the universe over the past 30 years. But of course, it had a wonky mirror. And this was a cartoon from about the time. And I thought this was particularly funny, very clever. So we've got a wonky mirror, and we've got distorted pictures of the moon. We've got distorted pictures of Jupiter. And then we've got wavy rings of Saturn. And then looking back at the Earth, we see the distorted and angry faces of the US taxpayers, because it only cost $2 billion to fix it. So they installed, using the space shuttle, of course, they took up CoStar, which was the corrective optics package, which fixed the mirror. But as I say, it took 3 years and $2 billion to fix that particular problem. So we look at the M100 spiral galaxy. We look at the first picture that was taken. You've got this fuzzy, horrible picture, which horrified the scientists at the time. And of course, the reason it went up with this wonky mirror was because NASA management, senior management, refused final testing of the mirror. Fortunately, they haven't made that mistake with the James Webb Space Telescope, which more on that later. So this is the after the fix. So you can see this beautiful image of a spiral galaxy M100, a much improved image. So, and over 30 years, of course, the Hubble has given us fantastic service. It's had to be repaired a few times, 5 different service missions, but it's told us more about the universe than any other telescope. But it could have thrown up some surprises, of course. You know, every time they put a new space telescope up, they get surprises. So it could have been quite embarrassing. I mean, you know, it could have proven that we live on a flat Earth. What would have happened if that had thrown up? 1993, Fermat's last theorem, which was first proposed in 1637, was finally proved. Fermat wrote in the margin of his notebook, well, I've got an answer to this particular problem, but I don't have room here to put it in. And only I wish he had, because it took nearly 400 years to just sort it. And basically, it's this formula here, a to the n plus b to the n equals c to the n for any integer greater than 2. And just trying to prove that took Andrew Wiles quite a few years, and some of the most advanced mathematics ever invented. Here he is, the chap himself. 1994, the Hubble Space Telescope confirmed the existence of a black hole in the M87 galaxy, 50 million light years away in the constellation of Virgo. And its mass was 6 billion times the mass of the Sun. So absolutely immense thing. In 1994, they observed, again using Hubble, the Schumacher-Levy 9 comet breaking up actually and landing and colliding on Jupiter. Some spectacular pictures. 1994 as well, the first of the breast cancer genes was discovered, BRCA1. There are now BRCA2 and others, of course, which has led to early diagnosis and treatment. 1995, the second US-Russian space docking occurred between Atlantis and the Mir space station. 1995, the first exoplanet or extrasolar planet was discovered, 51 Pegasi, 50 light years away from Earth. And of course, nowadays, we know a lot more. Then 1995, the discovery of the top quark. This was the last in the set of 6 quarks, was finally discovered in Fermilab in the USA. 1996, Pope John Paul II affirmed evolution by natural selection. Again, only 137 years late. And then Dolly the sheep in 1996 was cloned by the Roslin Institute in Scotland. And then in 1996, a new class of life completely. So a third branch of life, in addition to eukaryotic life and bacterial or prokaryotic life, was a new form called archaea, single-celled, simple, a bit like bacteria, but significantly different. 1997, there was a microscopic analysis of meteorite, which led to the belief in ancient Mars, life on ancient Mars. That was finally debunked. Pathfinder, the vehicle, the little rover, photographed Mars and studied it. So a little rover was called Sojourner, and the mission was called Pathfinder. But the very latest rover on Mars, of course, is Perseverance. And we've got one of the very latest pictures, breaking news. There we go. It's the latest picture from Perseverance. So until the 21st century, the scientists had assumed the universe expansion was slowing, and that gravity would pull matter back together again and slow the expansion of the universe. But in 1998, two teams of scientists studied things called Type 1a supernovas, which can be used as standard candles for measuring distances quite accurately in the universe. And they discovered, in fact, that the expansion of the universe was actually accelerating. And that led to the so-called dark energy hypothesis. But again, you know, it's amazing what we're constantly finding all the time. So now, along with antimatter and dark matter, we've recently discovered the existence of doesn't matter, which appears to have absolutely no effect on the universe whatsoever. 1998, human embryonic stem cells were isolated. And of course, these cells can be transformed into virtually any cells and tissues within the body, which promise new therapies. But obviously, the source of these cells was very, very controversial indeed. Obviously, people were very reluctant to use them, and also it led to bans on the research in America. 1999, Peter Gamble and his team at Bell Labs and Lucent Technologies came one step closer to creating the small, super thin cell phones that we see on the market today. They used a thing called micromachining to reduce the size of three crucial parts, electronic parts, and fitted them onto a single chip, which led from something like this brick, to the things that we have today. And then 2000, the tau neutrino was discovered. That's the last of the leptons, of six different leptons. It's all part of the standard model of particle physics. And this was discovered by again at Fermilab, by the donut experiment. 2001, a paper reported the initial sequencing work. They'd done 94% of the human genome and had published the first draft of the 3 billion base pairs that make up human DNA. 2001, the age of the universe was confirmed, again using Hubble Space Telescope, plus other things such as the boomerang balloon flights and other data, and set the age of the universe to be 13.7 billion years. And of course, now we know it's actually nearer to 13.8. 2002, solar neutrinos were seen to change via a process called neutrino oscillation, and they found that they must have a very tiny, but as yet undetermined mass. And they're still studying these in great detail. And again, a lot of that work is being done at Fermilab. 2002, this is quite complex charge parity violation. Basically, what it's saying is they've detected differences between antimatter particles and matter particles, because for all matter particles, there are equivalent antimatter particles. And what they've found is an asymmetry in between matter and antimatter. And what this was telling them basically, or was beginning to get information which explained why, when the universe was created, equal amounts of antimatter and matter were formed and should have all annihilated. There should have been nothing left but a huge gamma ray pulse in the universe. But there isn't, of course. We are the material that's left over from that annihilation. So there must have been an asymmetry between matter and antimatter. 2002, anthrax toxin structure was determined, and that obviously led on to modern treatments for anthrax. 2003, again, this sad disaster, the Columbia Space Shuttle. This was damaged on launch, unknown to the NASA scientists, and sadly broke up on re-entry into the atmosphere, killing all the 7 astronauts on board. 2005, it was confirmed that higher levels of CO2 expected to be in the atmosphere by 2050 will actually cause trees to grow at a much faster rate. 23% is what they've actually measured. So if the atmosphere does become significantly increased in CO2, then we've got some hope that the trees will start to take that up in large amounts. But of course, we've got proof of climate change now. We know it's getting warmer. We can tell that, quite easily. Things must be getting warmer. And then, of course, we've got the effects of the Statue of Liberty in New York. She's shed her robes and is now stood there in a bikini. So we know it's getting warmer. 2005, the blueprints for the cell's protein factory were determined. This is the thing called a ribosome, which basically builds proteins. So what you've got here in this diagram, this thing is a ribosome. This is the DNA material going through the ribosome. Well, it's actually RNA, strictly speaking, but it's transferred from DNA. And then this thing here, all of the materials are coming in and are being assembled onto this, which is the structure of the protein which this ribosome is building. Now, these ribosomes are unbelievably complicated things, and they managed to determine the whole structure, which was incredible. 2006, some paleontologists at Chicago University, Neil Shubin and his team, showed the first evolutionary links between fish and the animals that evolved to live on land 275 million years ago. So this Tiktaalik rosea, which is an extinct fish-like creature with scales and the long body of an alligator, is thought to be the ancestor of creatures that began to live on land. But some discoveries are extremely hard to explain. I mean, how would you explain this? In 2007, skin cells, just plain old skin cells, were converted into stem cells. And this is a major breakthrough because using these techniques, they could create what are called pluripotent stem cells just from skin tissue, which means they didn't need to use embryonic stem cells in terms of research and also in terms of therapies that might emerge from the use of such stem cells. So now we've got many different sources of stem cells and have no need to use embryonic stem cells, which is a big relief. 2008, a new form of extinct archaic human was discovered called Denisovans. They're called hominins, which are the more modern branch of human type creatures. And evidence was found in a cave in south central Siberia, on the borders of Kazakhstan and China and Mongolia. And this is where it is on the map. You can see there's India, and this is where the actual evidence was found, where the cave is. And believe it or not, the cave, it was named after a chap called Denis, a Russian hermit who lived in the cave for many years. And they called the the new species denisovans in his honour. And what they actually found, they found more evidence since, but they found the finger bone of a female adolescent. And fortunately enough, there was enough material in it to analyze the mitochondrial DNA. If anybody wants to know what that is, I'll explain it later in the questions. So the first extinct animal was cloned. Of course, we all want woolly mammoths to be cloned, or a saber-toothed tiger to be cloned, or whatever, but that's still the stuff of science fiction. But the first extinct animal was cloned in 2009, and it was actually a Pyrenean ibex. Now, it was sadly the clone died shortly after birth, but it was still considered to be a major substantial advancement in science. 2010, chemists or physicists stroke chemists were looking for the so-called islands of stability. In other words, creating elements heavier than those that occur in nature, looking for, hopefully, a region where the elements created would be stable for a significant periods of time. And so they're building these super heavy elements in colliders, going way beyond uranium, and they came up with this tennessine. It's 117, bearing in mind that uranium is 92. So they've significant progress, but again, very quickly, they were trumped by this one, organesson, which is 118. But these things only live for a tiny, tiny fraction of a second. 2010, some colleagues, Gordon Anderson and his colleagues at CERN, created anti-hydrogen and managed to trap it. 38 anti-hydrogen atoms were created and trapped in the alpha experiment. So what they did was they took an anti-proton, which is an antimatter version of a proton, which is the nucleus of a hydrogen atom, and they added to that positrons, which are the positive version of electron or an anti-electron, and they created in this trap system 38 atoms of anti-hydrogen. And as we know, antimatter is, well, it's the most efficient fuel you could possibly get. It annihilates with proper matter with 100% efficiency, turning all the matter into pure energy. But it's very, very expensive to produce, extremely expensive. So we won't be using it anytime soon as a fuel in our warp drives. 2011, a paper described for the first time the atomic structure of a thing called a G protein coupled receptor. So what they did, again, this is very, very complicated protein structure. And again, they got the Nobel Prize for this. This is a major, major achievement in terms of working out these receptors, because they're involved in our body where we're responding to hormones and neurotransmitters. And so it's very important to understand these receptors so we can make drugs to actually target them and interact with them in an appropriate way. 2012, we found the Higgs boson at last. We finally proved it existed. And it took the Large Hadron Collider and these two huge experiments, one called ATLAS and the other one called CMS. And these two teams worked independently of each other. And eventually they came together in 2012 and compared their data and proved that they've measured the same, essentially, mass at I think it was 127 GeV. So they got, again, Peter Higgs got the Nobel Prize with his colleague Francois Englert, but unfortunately the third member of their team had passed away, and they don't award Nobel Prizes posthumously. And of course, the Higgs boson explains how the building blocks of the universe acquire their mass. 2012, a new genetic editing technique came on stream called CRISPR. This is a way of editing DNA in a very, very precise way. And you can literally snip the DNA, as shown here with these tweezers, and then you can replace it or substitute it with the DNA that you want to put in. So you can nip out a single base pair. So very, very precise editing, and getting more and more precise as the work continues. And it uses a thing called Cas9 protein, which is programmed to find a specific bit of DNA. And then it uses a piece of RNA to guide the search, and you can do very precise genetic editing. 2012, in a car park in Leicester, hosted a scene worthy of Shakespeare. They found that the body of the former King of England, Richard III, in a car park in Leicester. And in actual fact, what they did was they examined the skeleton, and it had the spinal curvature expected, and the DNA evidence, and from his very distant relatives, actually proved it was actually, in fact, his body. 2013, 3D printing was beginning to make massive strides, and even Barack Obama, in one of his State of the Nation addresses, said it will revolutionize the way we make almost everything. And in that year alone, they managed to print stem cells, a car, artificial ears, artificial bones, and more. And in fact, now they can 3D print using metals. They regularly build titanium parts with 3D printing. 2014, stem cells were first used to cure paralysis. So after being paralyzed in an attack by a knife-wielding attacker, Derek Fidger regained the ability to walk in 2014, thanks to a stem cell treatment. What they did was they took some cells from the patient's nose and they inserted them in the spinal cord. They modified them and inserted them in the spinal cord, and using some nerve tissue from his ankles, they bridged the gap in his spinal column. And after a few years with some assistance, he learned to walk again. 2015, a one-year-old girl received cancer treatment using gene therapy at Great Ormond Street Hospital, curing her leukemia. 2016, gravitational waves were seen for the very first time by the Laser Interferometer Gravitational Wave Observatory, or LIGO, and there are two of these observatories in America, one in Washington State and one in Louisiana. And there's another one in Italy now called Virgo, and I think they're building one in India as well. So, they managed to detect the collision of two black holes, one 29 times the mass of the sun and the other one 36 times the mass of the sun. And this coalesced to form a black hole of 62 solar masses. And those quick with maths will see there was some mass missing, and that was converted. So 3 times the mass of the sun was released as pure gravitational wave energy into the universe. 2010, we knew by then about 450 planets beyond our solar system. Now that number has grown to more than 5,000 confirmed, and they've even found planets around the nearest star to the Earth, which is Proxima Centauri. And they're now, actually, they think they found a third one. So there are 3 planets now around Proxima Centauri, which is only 4.24 light years away from Earth. 2016, an artificial intelligence from DeepMind beat the world's best Go player, which was thought, this problem was thought to be computationally totally intractable. They thought we would never have computers that could beat humans at Go. DeepMind proved that not to be true. It was a dual deep neural network, and it was trained by a process called reinforcement learning, and it was trained using classical games and also self-play. It was allowed to play itself hundreds of thousands, if not millions of times, and he beat Leigh Edwards, the world's best player, 4-1. So a very convincing victory. And of course, artificial intelligence is advancing all the time. But what if it gets too smart, you know? So now, you know, we're looking at the Department of Machine Poetry Research, all these machines developing poetry. But 2 chaps having a discussion, the poetry is absolutely dreadful, but anything that distracts them from rising up and enslaving us all has to be a good thing. 2017, a gravitational wave signal was detected by LIGO and Virgo. This was two neutron stars merging, which are again remnants of dead stars, but smaller than black holes. These merged to form a black hole. And in the process of doing this, when black holes merge normally, they don't release any visible light or anything you can measure with telescopes, but neutron stars do. So they managed to observe it as well using optical techniques. And this kilonova explosion produced 16,000 times the mass of the Earth in heavy elements, including about 10 times the mass of the Earth in gold and platinum. So that's where most of the gold and platinum in the universe actually comes from kilonova explosions. 2018, very controversial. CRISPR, this genetic editing technique, was used to modify two embryos, and two babies were born, twins. It was monumentally controversial because these gene-edited babies created in China, actually what they did was modify their, what they call their germline, which means that if these two girls go on to have babies of their own, they will inherit the edit that was made to them. And it will go on generation after generation after generation. So he's now actually languishing in a Chinese jail somewhere because he didn't seek proper approval. 2019, the first image of a black hole was captured. This used 8 different radio telescopes around the globe and linked with very, very precise atomic clocks to combine all the data. So they gathered all the data and then processed it on a massive computer system. It was called the Event Horizon Telescope, and it produced this image of M87 with this massive black hole, 6 billion masses of the sun at the center. And it's 1.6 million light years away. So an amazing achievement. 2019, you may have heard of quantum computers, and work is advancing all the time on developing these things. But in 2019, Google claimed quantum supremacy, which is essentially what they said was, we've built a computer that can do certain calculations faster than any other computer that could ever be built. And immediately that was counterclaimed by IBM. They refuted the claim completely and said that Google exaggerated. But either way, what this means is there's very hot competition out there for developing quantum computers. And they are making very, very good progress. If we can get quantum computers that can do general purpose computing, then they'll make the computers we have now look like mere abacuses. 2020, of course, because of the COVID pandemic, there was open public access for all of the research that was being done into COVID-19 was made available on servers, and it was open public access. So this was a massive sharing of all of these data, resources, genetic sequences, everything on a never before seen scale. So this worldwide collaboration allowed real-time data to be shared instantly across the planet to counter the virus. And that, of course, led to things like the mRNA vaccines and so on. And of course, the Oxford one, which is a conventional vaccine. But on the subject of COVID, of course, got some interesting sort of observations. George W. Bush, I caught Saddam Hussein. Barack Obama, I caught Osama bin Laden. Trump, I caught COVID-19. And of course, being the eminent scientist that he is, he invented his own treatment all by himself. And here he is undergoing treatment. And I couldn't resist this one, but I've just read in In Maryland, in America, a US priest has died after injecting himself with disinfectant. And I don't know how true it is, but according to reports, Donald Trump is being charged with the bleach of the priest. Of course, 2021, we've got civilians, even more civilians into space. We've got Jeff Bezos, William Shatner, Richard Branson, etc. So this is becoming very, very common now for people to go into space. But I'm struggling to understand the hype about Jeff Bezos and Richard Branson when a guy from Wigan and his dog reached the moon in a homemade rocket in 1989. Why is the media silent on this? Okay, James Webb 2022. So this was launched finally after 12 years of delay, launched in actually December the 25th, 2021. It's now up in space. It's completely unfolded. It's cooled right down, and it's ready to start giving us some amazing results. This is Hubble on steroids, and it's going to blow us away when the results finally come in from this. We can expect the first results around about June, July. They're still tweaking it, tuning it, but everything has worked. This could have gone wrong in 345 different ways, and so far everything has worked perfectly. And so we're going to get some of the most amazing results from this telescope. It will take us right back to the early stages of the universe. So many advances in the past 400 years are due to the scientific method, of course. Basing what we know on experimental evidence, not prior authority, received wisdom, or personal belief. So we make careful observations, we gather evidence from experiments and measurements, and that, using careful scrutiny with challenges from other people over the past 400 years, and particularly the last 100 years, have led to huge developments and an ever-increasing rate of development. A lot of knowledge these days, though, is also based on theoretical calculations and computer modeling, because some experiments you can't do in the lab. If you want to learn more about a black hole, it's not advisable to create one in the lab to study it. So most advances are over the past 100 years, and very, very many in the last 60 years. And a couple of examples just to illustrate just how fast some things are moving. So around about a century, the cost of computation has come down by a factor of 10 to the 18, believe it or not. So by 1 million times. Memory storage and capacity costs have reduced as well by similar factors. These are exponential improvements. About every 18 months, the power of computers doubles. The Human Genome Project I mentioned earlier took 13 years to complete this 3 billion base pair analysis of human DNA. And the cost was about 2.7 billion to do that first analysis. The world record has just been broken, 5 hours to sequence the whole of the DNA of a newborn baby. This baby was born with a genetic disease, and they needed to find out what it was, and they did it in just over 5 hours. So costs have dropped to about $1,000 now to sequence a human genome. So a factor of 2.7 million in 20 years, which is incredible. So that will lead to personalized medicine. So in other words, you'll be able to have your DNA analyzed, and you'll be able to not only fit drugs and therapies specific to your particular personal makeup. So we've mapped all the genes in the human genome with about 23,000 genes, but now we've got the Human Proteome Project, because genes in general code for proteins, and so far they've identified over 19,000 of these proteins. About just over 90% have been covered to date. And what is really important to do is to work out what these proteins are and what they do, so we can understand the biochemistry of the body. And part of that understanding is the structure. And proteins they have tertiary structure, they have primary, secondary, and tertiary structure. And it's the shape of the protein that's absolutely critical in how it works inside the body. And they now have artificial intelligence that can predict the folding very, very accurately. So DeepMind again, the people who made the AlphaGo, have come up with AlphaFold, and they're now mapping all of the folding of most of the human proteins. And of course, we know that some proteins, when they misfold, form things called prions. And that, of course, was the basis of CJD, Creutzfeldt-Jakob disease, and BSE in cows. They also know now that some misfolded proteins are implicated in Alzheimer's disease and also in Huntington's and Parkinson's disease. So it's crucial to understand how these proteins fold and also misfold. So we will get new diagnoses, new treatments, new drugs and therapies as a result of this work. And it's advancing at an absolutely astounding rate. So there'll be more change, I think, in the next 40 years than the last 400. Eventually, we will merge quantum mechanics and general relativity to a single theory. And when we do, the effects will be revolutionary. Gene therapy, stem cells and genetic engineering will be used for more and more incredible healthcare in the future. We will get control over infectious diseases, degenerative diseases, and cancer. Longevity medicine now is a real thing. There will be regenerative medicine to not only stop you aging, but to actually reverse the effects of aging. And this will lead to massive health span increases. So in other words, the time you remain healthy before you finally become ill and die. Artificial intelligence advances are moving at a huge pace, and we are already beginning to see now artificial intelligence emerging with human brains. So Elon Musk has got his Neuralink project, and that's looking now to go into trials. And so with vastly increased computational power and eventually artificial general intelligence and possibly superintelligence, these advances will move at an even faster rate. Food production, as we know, well, that will have to change. And in the future, it will be unrecognizable by the people of today, because we've got to change this because of climate and also because of the increasing population. Data, of course, now available in vast amounts. Data is the new oil, and the amount of it will continue to grow. And that data will be used in ways we can't yet imagine, primarily by artificial intelligence. 3D printing of everything from organs, bones, complex components to complete homes. Material science will create metal alloys, ceramics, and composites of unimaginable properties. Renewable energy is obviously on the increase, and fuels, new fuels such as hydrogen and ammonia, used as energy storage, will eventually replace fossil fuels. And of course, we're all hopeful that fusion energy will be cracked in the not too distant future. And we will eventually gain control of the environment, we'll control pollution, we'll limit the loss of biodiversity, and we will learn to conserve the valuable resources that are so limited. And eventually, of course, we will establish permanent bases on the moon and on Mars, and in particular in Earth orbit, where people will live permanently off the Earth. But don't despair, don't despair. If you ever think your brain is inadequate, think of this guy. And don't forget, always remember that behind every great man, there is also a great woman. So there we go. Any questions? I'll gladly take any questions.
Leigh, that was absolutely brilliant. I really don't know.